Determine whether a normal sampling distribution can be used. If it can be used, test the claim. Claim is P is greater than or equal to 0.48, alpha equals 0.08. Your sample statistic is P hat equals 0.40, and your sample size is 90. To determine whether a normal sampling distribution can be used, we have to calculate NP and NQ. Both of these have to be greater than or equal to 5. P is going to be from the claim, so we have 90 times 0.48, and we're testing, is that bigger than or equal to 5? 90 times 0.48 is 43.2, which is bigger than or equal to 5, so that part checks out. Now let's do N times Q. Remember that Q is 1 minus P. So we'd have 1 minus 0.48. So Q is 0.52. So we would have 90 times 0.52. Is this bigger than or equal to 5? 46.8, which is bigger than or equal to 5. It checks off, which means that we can use a normal sampling distribution. Now that we know that we can use a normal sampling distribution, let's test our claim. So first of all, let's state what our null and alternative hypotheses are. The claim includes the equal sign, so that means that the claim is the null hypothesis. The alternative hypothesis would be the complement, or P is less than 0.48. Now that we have the null and alternative hypothesis, let's find our critical values. To find our critical values, we're going to have to go to the z-table. In this problem, our alpha is 0.08. So first, let's draw a picture to see what we're looking for. Look at the alternative hypothesis to determine if this is a left tail test or a right tail test. Since the alternative hypothesis has a less than sign, this is going to be a left tail test, which means that we're looking for a negative z-value. And specifically, the area under the curve is going to be equal to your alpha value of 0.08. So when we go to our table, we're going to look inside the area of the table for a number that's as close to 0.08 as we can find. Here I am at table 4, and I want to scroll down and look in the body of this table to see if I can find as close to 0.08 as I can. And when I scroll down, I see this value of 0.0793. I also see 0.0808. And actually the 0.0793 is the one that's closer. Therefore, that's the one that I'm going to use. And that corresponds with negative 1.4, and I'm going to have to scroll up. Negative 1.41. So my critical value here is negative 1.41. Now let's figure out what my standardized z-test statistic is. So for that, I'm going to use the formula z equals p hat minus p divided by square root pq divided by n. Okay, let's substitute in our values. P hat is 0.40, P is 0.48, so we have 0.48 times 0.52 divided by 90. So here in the numerator, I get negative 0.08. In the denominator, I get 0.0527. This is approximately equal to negative 1.52. When I go and plot this on my standard normal curve, notice that I'm plotting it in the rejection region. So this means that I'm going to reject my null hypothesis. So what does that mean? Remember that the reclaim was the null hypothesis. Therefore, we're rejecting the null hypothesis. So my conclusion is that there is enough evidence at the 8% level of significance to reject the claim. A researcher claims that 85% of Americans think they are unlikely to contract the Zika virus. In a random sample of 250 Americans, 225 think they are unlikely to contract the Zika virus. At alpha equals 0.05, is there enough evidence to reject the researcher's claim? Part A, identify the claim and state the null and alternative hypotheses. Let's highlight the claim, and the claim is that 85% of Americans think they are unlikely to contract the Zika virus. Now let's write this in mathematical terms. 85% is a percentage or a proportion, so our variable or our statistic is going to be the proportion or P. 85% of Americans think they are unlikely to contract the Zika virus. Notice that there's no key phrases like greater than, less than, at most. So this is simply going to be equals to 85% or 0.85. Now because this one has the equal sign, this is going to be our null hypothesis. So we're going to state that our claim is our null hypothesis. The alternative is going to be the complement, which is P is not equal to 0.85. Part B, find the critical value or values and identify the rejection region. I'd like to again point out that in your textbook there is a little table that gives you some common values. I've also got this in the Unit 7 study guide. Here's the table. So all we need to do is look at this table and identify what our critical value is, because notice that they're using an alpha value of 0.05, which I have on the table. This is going to be a two-tailed test because we're testing the null hypothesis P equals. So since it's a two-tailed test, our critical value is going to be plus or minus 1.96. Let's look at this on a standard normal curve to get the rejection region. This area under to the left of negative 1.96, to the right of positive 1.96, that's going to be our rejection region. So to state our rejection region, we would say that our test statistic has to be less than negative 1.96, or Z has to be greater than positive 1.96. Part C, find the standardized test statistic Z. First, let's write out the formula for Z. Notice here that there's a couple of things that I don't already know in this formula. First, I need to calculate P hat. P hat is equal to X over N. From our sample, this means that there's 225 divided by 250, and this is equal to 0.9. Next, I also need to find Q. Q is 1 minus P. Now don't get confused between P and P hat. P is going to be what's in the claim. So this is 1 minus 0.85, which is equal to 0.15. Now let's take our numbers and plug it into our formula. In the numerator, I have 0.05, and the denominator simplifies to approximately 0.0226. And this value here is approximately equal to 2.21. So my standardized test statistic Z is 2.21. Part D, decide whether to reject or fail to reject the null hypothesis, and then E, interpret the decision in context of the original claim. Let's list out what we have so far. Okay, so here we have all the answers from our first three steps. Now what I want to do is I want to take this Z value, standardized Z test statistic, and I'm going to plot it on my normal curve. When I plot it, I notice that I have it in the rejection region. That means that I'm going to reject the null hypothesis. So now let's look at what this means in context of the original claim. Again, let's look at the question. It says, is there enough evidence to reject the researcher's claim? Since we are rejecting the null hypothesis, we are rejecting the researcher's claim. So we would state it in words as such. My conclusion is there is enough evidence at the 5% level of significance to reject the medical researchers' claim that 85% of Americans think they are unlikely to contract the Zika virus.